Hello, everybody. Welcome to this session about serverless integration on Kubernetes with Apache Camel K. My name is Nicola Ferraro. I work for Red Hat, and today we are going to talk about, first of all, Apache Camel, what is this, Camel K, how it fits in the serverless space, and especially in Knative, and then I will show you a demo and talk a bit about future development. I'm Nicola Ferraro. As I said, I work as principal software engineer for Red Hat. My Twitter handle is _Ferraro if you want to be updated with the latest news about Apache Camel. Because I work on Apache Camel, I work on Camel K, also on Red Hat integration, and from time to time I also contribute to Knative. So let's start talking about Apache Camel. I know that some of you may not know about it. So this will be a brief introduction, but I'm not going into much details. We'll just give you an idea. So I think that many of you have experienced this joy of developing things. Software development is fun after all. So when we start a new application, for example, many times we want to do it with the best of breed of technologies that is available. We want to do it serverless, and we want to use whatever is needed at best suited for the application that we want to write. But sooner or later, you realize that, your application doesn't live alone in the world, because there are a lot of other applications that you need to connect to because you want to use their data, because they want to use your data. So it's an ecosystem. We are putting your application not alone, but it needs to communicate with others. And communication is hard. So when you want to connect, to integrate even two systems, you need to face a lot of communication problems. So one application may be synchronous, the other one may be asynchronous. They may use different protocols, different languages. They for sure have different business domains, so you have to map objects from one side to the other, and different data access pattern. And once you fix all these problems, you have another set of problems, like what happens if the other application becomes unavailable? How to deal with consistency issues when there are failures in the other side, only on your side. And also, sometimes you cannot change the other side because you have different ideas and you have to do all the integration from your side. So these are some of the problems that happens when you try to integrate two systems. So we need some tools, okay? And we need a tool, the perfect tool that can help us integrate two systems should have, for example, connectors to be able to connect to any kind of technology protocol that is available from the other side, or also software as a service. It should be based on well-known integration patterns, for example, because we don't want to reinvent the wheel anytime we need to connect another system. And also, it should work on and off the cloud, on Kubernetes, on Knative, but also without that. And it should allow you to integrate systems with a simple language, for example, a domain-specific language that can allow us to say, let's move data from here to here, like this. All this is Apache Camel. Apache Camel is a project, an Apache project that started some years ago and allow you to integrate a system with this. So let's make an example to make this clear. So let's suppose that you want to create your application using Knative, but you have to connect and share that with other applications, one developed with Pulsar and the other one that uses Kafka under the hood. So how do you share data with them? For example, you can create a Camel integration that has this simple language from Pulsar to Knative with some transformation in the middle. So this is a Camel language. It's a domain-specific language that allows you to move data. And you can look at the language. I'm not going to explain all the detail of the language, but it's self-explaining. I'm taking data from a Pulsar topic in a specific namespace and converting it into a cloud event that can be received by my application inside Knative. We'll talk more about the Knative later. And I can do it also in the other side. I want to move data from Knative to Kafka. What I can do is to listen for all events generated by my application on Knative and then send them to a Kafka topic after doing some transformation. For example, in this example, I getting a file from S3 using one of the many components, AWS to S3, that is available in Apache Camel. With these two integrations, basically, you can do whatever you want in the party area in the middle. So use whatever you need. And specifically, we provide a lot of useful things for building applications that are serverless and based on Knative, as we will see. Okay, Apache Camel is a project that is more than 10 years, but this is something really cool because we have a huge community. We have a lot of new users also recently because we have started creating some awesome sub-projects. One of them is Camel K. And Camel supports a lot of components, 346 as the last time I checked. All that components allow you to connect to a specific protocol, to a specific external system, like the ones that you see here in the picture, like Twitter, Salesforce, but also all protocols and software as a service, but also middleware and other platforms that are available out there. So everything you can imagine can be connected with Apache Camel nowadays. And so now we can talk about this sub-project called Camel K. So Camel K is, we say it's a lightweight integration platform born on Kubernetes with serverless superpowers. So it's a project that we have started 2 years ago, and it's about running the Camel DSL, the Camel code that integrates system directly on a Kubernetes cluster. Latest release 1.0 was released 2 months ago, basically. So the idea of Camel K is simple this. You create this simple DSL, this simple language that tells how to connect to systems or more systems, not limited to only 2. And once you've created this file, you have the CLI called Camel with the K, and you type camel run, the name of the file that contains your integration, and you are connected to an OpenShift cluster or to a Kubernetes cluster. It works in any environment. And this integration basically runs as a pod with other resources created for let this integration run. Everything in Camel K is code-driven. So you have just to write this code, and everything else is managed by an operator. It's called the Camel K operator that you can install on a cluster. It's available on Helm. It's available on Operator Hub. And the basic workflow is this. The developer creates a file with the integration routes. The routes are the things that I've shown you before that connect systems. These routes are wrapped into an integration custom resource. It's a Kubernetes custom resource called integration. Then the operator takes this custom resource and converts it into running pod in functions, services, and whatever is needed to run that integration from the code. Everything, as I said, is code-driven. It means, okay, let's skip the slide. It means that you can write the integration here, and it says that in this case, I'm exposing an API. I'm using the native HTTP Camel component, and then sending the data into Knative. It means that from the operator point of view, the operator parses this code and says, okay, we need to use the native HTTP component, which is a Camel library, the Knative component, which is another Camel library. Then it pick all these libraries that are needed. It creates a container image for running this integration. Camel under the hood is based on Java, but we will see that we will have more optimization in the latest slides. This creates a container image for you, creates all the services, so the deployment, the secrets, and the config maps to let this run. And it can run as a serverless integration on Kubernetes. So this is how it works. Let's skip this and talk about Knative a bit. So Camel K loves Knative. So this is a love story that started 2 years ago because the two projects started almost at the same time. This is not the official logo of Camel K, but somebody put the Camel logo and the Knative logo together, so it reads as Camel and K. So we like this, but it's not the official logo. Camel K can work also without Knative, but yeah, it's better when they run together, just this. Just to be on the same page, I'll give you a really brief introduction about Knative. So Knative is about serverless, and it's a series of building blocks for running serverless application on Kubernetes. The building blocks are divided in two main parts. And one is called Knative serving, that is about autoscaling, and the other one is about Knative event, that is about event-driven applications. Okay. So when we talk about Knative serving, the most important building block is a custom resource called Knative service. You can create a Knative service to run your container, and if there is a request for your container, for your service, then a pod will be created to serve the request. But as soon as no request arrives for a certain amount of time, this pod is destroyed, so the service scales down to zero. And it works also when you receive multiple requests, so multiple pods can be created by the Knative services, so to serve these requests in parallel. When using Camel K with Knative, so basically nothing changed from a developer point of view. So you created the Camel DSL. In this case, I'm creating a REST endpoint called path with a post method that whatever you send to this endpoint is sent first to system 1, and then the response from system 1 is sent to system 2. System 1 and system 2 are just to place order for one of the 350 and 60 components that are available in Apache Camel. That can be any software as a service or any protocol that you can imagine. This REST DSL, this Camel DSL, is converted automatically into a Knative service, so you have auto-scaling automatically. But from a developer point of view, everything is code-driven in Camel K. Talking about Knative eventing, it's about event-driven application. The most important building block here is called broker. So the broker is an abstraction, is an interface for a publish-subscribe resource. You can send events to the broker, and you can let services, with the ones that you see on the right, to be triggered when a certain event with certain features is published into the broker. So this is how it works. When it comes to Camel K is really awesome to be used in this context because you can create event sources from many components that you have. So you can take, for example, all the tweets that talk about a certain topic and send them into the broker so that application can subscribe later. But also works in the other side. For example, suppose that you want to send emails to your customers, and so you can create a Camel K integration that converts an event into an email that is sent actually to the customers. And so from your application, you can just publish an event, and that will be converted automatically to an email that goes to your customers. But not anything here should be done with Camel K. You can use Camel K whenever it's needed to do integration with other systems or do transformations, and use the technology that is best fitted for all the rest. And so you can plug whatever you want in Knative eventing. Just one thing before we start the demo. I told you that the main way to use Camel K is to create a file with the Camel DSL, and then this file with this Camel CLI is converted to an integration custom resource, and then the operator creates some running pods, Knative services, and whatever is needed to run the integration. But there is a second way to run Camel, especially when you want to create sources. You can directly create a Camel source that is a custom resource that belongs to Knative. So this is released together with Knative, and it wraps a Camel K integration. So they have the same power, the same expressive power, but the Camel source is compatible, for example, with the KN toolings. That is the de facto CLI. It's the official CLI for Knative, so it recognized by that, but also by all the tooling that is based on top of the Knative interfaces. Just that, but from under the hood, they are almost the same thing. So we can now start the demo. Okay, this demo is about Bitcoins. You know probably that today 1 Bitcoin is worth about $9,000. That seems something crazy. But the question is, should I buy more Bitcoins or should I sell if I have some Bitcoin in my portfolio? So let's try to answer this question by building a system that can predict if the price is going up or if it's going down. So we will use an existing machine learning algorithm that some other team has developed and create something using Camel K. So listen for the real data that comes from the Bitcoin market, push this data inside the Knative broker, and then create some bridge to send the current value of the Bitcoin versus US dollar to this machine learning algorithm, listen from some prediction from it, and then send the prediction back to the broker where there will be some sinks. In this case, I'm creating a sink that will convert the prediction into a message that will go into my smartphone. So I see that if I need to buy or sell Bitcoins directly, and I'm using the Telegram component from Apache Camel. Let me share my screen, and we can start the demo. Okay, I hope you can see the screen now. I have here an OpenShift cluster where I've already created a namespace called the Camel K Native, and I've installed the Camel K operator that can be also installed globally. I've also enabled the Knative broker here, so you see here 2 pods. In the latest version of Knative, the broker is multi-tenant, meaning you can create it in your namespace, but it won't create these 2 pods because they will be global. Here I have deployed also the Quarkus-based machine learning algorithm. We will talk more about Quarkus later. It scaled down to 0 because this is a Knative serving service. Okay, let's do the magic with Camel K. So let's start with this. So this is an example made with Didact, so you can follow it. There are instructions on how to run it on your own. You can find the links in the slides. Okay, let's start from the end. We want to listen some prediction in the event measure from the broker, and then transform this prediction into a message to our Telegram chat. So in order to do this, you can create, for example, using the Camel CLI, an empty file like file.java, and it will create a file. But here, because we don't have a lot of time, I will show you directly the integration already done. So this is the sync that will transform a prediction into a message to our smartphone. You can read it as this. So we start from a Knative event called of type prediction.quarkus. So we can define our own types. We transform it to a string. So predictor suggests to buy or sell at this price. And then we send it to Telegram, to a Telegram chat. So this is using the Telegram component. You know that in Apache Camel, you have a lot of components. This is camelapache.org, and you have really a lot of components. You can filter here. And for example, the Telegram component that is well documented here, how to use it, etc. In this case, also I've installed also a plugin for the IDE, so I can also have auto-completion here of the properties that are available for the component, even if this is a string. So we convert an event into a message to our Telegram bot. So we'll see the message here in this Telegram chat, and that also on my smartphone. And we reply with an empty string to the broker, because the broker expects that we can return some response. But in this case, I just want to consume this event and send it to a Telegram. To run this integration, I'm going to run Telegram sync.java. And it also has loaded this property file that is declared here in the mode line. And this property file contains also the authorization token to talk with Telegram. If we go back to OpenShift that is running remotely on the cloud, we have created this Camel K integration. It's a pod. It is running currently, but it will scale down to 0 if there are no events coming to that. And currently there are no events because we have just deployed this piece. So we want, first of all, to create some data. But before going to do it, let's see what has been created. The K in my laptop is kubectl. So kget it means integration. There is an integration running. You can see it also from this panel here that belongs to the VS Code extension, VS Code plugin. So you can get, for example, KSVC. You see that there is a Quarkus application that is running as a Knative service, but also Telegram Sync is running as Knative service. And you can get also the triggers that are available in Knative. And we have a trigger here created for Telegram. Why? I will show you. So this trigger says basically that whatever is sent to the default broker in Knative with the attribute type equal to prediction.quarkus should be sent to the service called the Telegram Sync. But I've not created all this YAML by hand. This comes from the operator, because what we have done is to tell Knative, to tell the Camel K operator to create a trigger from prediction.quarkus from the default broker. So that all this has been created by the Camel K operator. You can add those additional filters. You can also receive different kind of event on the same integration. Okay, let's go back to the diagram and create the source. So as I said before, sources can be created as a Camel K integration and run with the Camel CLI, but they can also be created as custom resource belonging to Knative, so Camel sources. This Camel source is a YAML that contains the Camel DSL, but written in YAML. So we have many DSL, so you don't have to write them in Java. We can write them in YAML, as you see here, but also in Groovy, in Kotlin, and also in JavaScript if you want. So this is a variant of a Camel K integration. We start from the timer component. Timer creates a periodic trigger, basically, every 10 seconds. We use the exchange component from Camel to get from Binance the current value of Bitcoin versus US dollar. We transform that into a JSON, and then we log and set the content type, set the cloud event type to market Bitcoin and USDT. So remember this, and send it to the default broker. So to create this, we do kubectl apply in Ceph market source, and it has been created. Yes, now. So if I type source and source list using the Knative CLI, I see this source that has been created. And it has also created a Camel K integration, as you see here. We can follow the logs, and you will see that, yes, it's generating some JSON with this currency pair, Bitcoin USDT, the opening value. And last is the value that we are interested into, as you see here. So last is the last observed value of Bitcoins versus US dollars. So let's close this. This is running in a cluster, as you see here. This icon is because this is a standard Knative source. Okay, let's create the last piece of the picture. So this predictor that breached the Quarkus machine learning algorithm. Just let's see one moment the machine learning algorithm. It contains samples and point that can receive a JSON, but it needs to receive only a table value, so the current value, not the full JSON that we produce using the source. So we need some basic transformation using Camel. So let's do it. Just I'll show you briefly the code without focusing too much. We listen from the JSON produced by the source, using a Knative component, so it will create another trigger. And then we send this using the NetHTTP component. Don't care about the error, this is just the tooling. We send it to Quarkus ML using the sample endpoint, using a post. We set the content type and do set the transformation from the JSON to only the last value here, and reply nothing to the broker. And we take from the wire the response from the class, from the Quarkus service, which is a simple service, it's not a real machine learning algorithm, and we evaluate it. If the response is not empty, we emit the prediction. The prediction is something like buy or sell and the value at which you need to buy or sell. This is sent as cloud event. It's transformed into cloud event of type prediction.quarkus, so it will be received by the Telegram sync integration. Okay, let's run it. Camel run prediction breach. So it will run in the cluster. This has been already created. We can follow the logs from here, so it's already starting, and you should see this also here in the OpenShift console. You see that Quarkus and Telegram has been scaled down to 0, but now Quarkus is starting up because this integration is calling it, and if this generates some prediction, also the Telegram integration will start up. We see here that the prediction has been emitted, so the Telegram endpoint started, and we should see here, once this is ready, the prediction. To sell or to buy Bitcoin? Yeah, no, buy and then sell. So I told you that the machine learning algorithm is not so efficient, but yeah, you see that there are a lot of variation in the price of Bitcoin. So I think it's okay to say buy and then sell. Okay, but this completes the demo, and I'm going back to the presentation now. Okay, I think we are back to the presentation. And let's talk a bit about the future. So what I've shown you is that, not showing this to you, but actually this is what happens. When you run an integration, it runs as a Java pod. And you can also enable Quarkus. Quarkus is a framework for building high efficient Java applications. but what we do now is to create a Java application with OpenJDK, with the JVM, and then the Quarkus framework. What we are going to do in the future, and we are working currently on this, is to compile natively the code into a native binary that is comparable to what we achieve if we run a Go application, for example. But it has the full power of all the components that are available in Camel. We have started a project recently that is called Camel Quarkus, that is about running all the Camel components as native applications on top of Quarkus. Why this? Because if an integration now can use, for example, even 200 megabytes, and so you may be incentivized to, for example, run together the two integration. For example, the Telegram sync and the prediction bridge could have run all together, so we can Camel run all the files that you want to run and give it a name, and it will run as a single integration. But you don't want to do it. You want to independently scale all the pieces of your code. So with Quarkus, you can lower the amount of memory that is used from 200 megabytes to just 25 megabytes. And also the startup time. You have seen that Telegram has started up in 5 seconds. So I've received 5 seconds later the message on my Telegram chat and on my smartphone. But with Quarkus, it can be less than 1 second with all this. So Mandrill is a new project to run Quarkus, to run GraalVM on top of OpenJDK, and we are going to leverage that. Another thing that we are going to use is Camelets. So we are working also on this. So why Camelets? Because many of you and also a lot of people don't know anything about Apache Camel and don't know how to write a line of Camel TSL, but they want to use these connectors that are available in Camel. So Camelets are about that. Experts will create those connectors for Twitter, for Salesforce, for ServiceNow, and then make them available so that you can pick one of them and then configure some parameters. For example, the query, I want to search all the tweets on Twitter that talk about Quarkus, configure the authorization token, and then choose a destination. This will be available also on the OpenShift console, for example. A destination can be the Knative broker or a Knative channel, a Knative service directly, or whatever you want, or even a Kafka topic. And this will run without writing a line of Camel TSL. Another important things on which we are working on is YAX. YAX is a framework for testing, for example, integration, but also general purpose service on the cloud. YAX is based on BDD style testing. So you define a feature file like this. Let's test this feature that the API gateway works, given this URL. When we send a get to a slash endpoint and we want to receive a 200 OK. So this seems natural language, but this is accessible via YAX that is based on Cucumber. So this will run and can be used to check if your service or your integration, in the case of Camel K, are working correctly. Okay, other important future developments are webhooks, because sometimes you need to have a pod. For example, the Camel source needs to have a pod that is always running, because we were doing polling from the Binance service because there is no webhook available. But for many endpoints, there are webhooks, and we're working on improving the number of components that can use webhooks to be called when there is a new data, and not to be always on and be called and call. Keda is another point where we're working on to have auto-scaling, not only for HTTP-based endpoint, but also for others. And if you want to learn more about Apache Camel, then there are other talks. Most of them are from DevNation. Klaus Ibsen, Andrea Cosentino have talked a bit about that. Also, we have a talk by Luca Burgazzoli and me on DevNation about Camel K, if you want to learn more about the details, because we have not a lot of time. So if you like it, Camel K, go use it, contribute with anything you have in mind. You also sign in bugs if there are. Yes, there are. Don't expect it will be perfect, but we want you to join the community and help us to improve it in the future. So follow me on Twitter, Ni_Ferraro, and yes, that's it. Thank you very much. Okay, so thank you for attending this session, and I hope you have enjoyed it, also the demo, and I hope I have not talked too much about details of Apache Camel. Yeah, you know, there are a lot of things to say, but yeah, many of you don't know Apache Camel, so it's difficult to explain it in details. So I will answer some questions that have been asked in the chat. First of all, someone is asking, what is actually Apache Camel? Apache Camel is a framework, is a Java framework. It has been around for a lot of time. It is one of the main Apache projects. And it is based on many components that are small libraries that are used inside Camel K. Camel K is written in Go because it's basically a controller, an operator for Kubernetes. But the runtime is still Java running on JVM. And so it supports many languages like Groovy, Kotlin, also YAML and XML. All of them can run on the JVM. And we plan, as I said in the presentation, to also run integrations on Quarkus with that advantage. Quarkus is a framework for highly efficient Java application that can run in the cloud. And the advantage of Quarkus is to make sure that some application, some integration in this case, can be compiled natively. So we want to compile our integration natively to be small and to be much more efficient and reactive, especially when running as Knative integrations. Another question that was asked is if you can run this demo on kind cluster, for example, on a local cluster. It's easy to run Camel K on Minikube. The reason is simple, because Camel K, as I explained in some slides, needs to create some images, because what you write is the DSL, but what you can run on a Kubernetes cluster is a container image. So this container image needs to be put somewhere. And while you have on OpenShift a default registry that Camel K uses automatically, while you can enable, for example, on Minikube, a registry that is available out of the box, it's the internal registry is not available on kind. But of course, Camel K can be also installed on kind. We also run part of our CI on a kind cluster. So yeah, it's possible to install it. We will make sure we have also a guide on how to install Camel K on kind, because this question has been asked frequently in recent times. So this is it. I'm not showing it. There is another question about can I develop Kubernetes cron job if we don't have Knative. What this means is that with Camel K, when you write integration, the integrations are materialized in what is most suitable to run your code. So if you create a periodic integration, the Camel K operator understands that instead of creating a deployment that is always running, the Camel K operator, if you use the cron component or the timer component of Apache Camel, it creates a Kubernetes cron job after the box. And you don't need Knative to have this cron job running, but it works on any Kubernetes cluster, any vanilla Kubernetes cluster. So this is it. I think I've answered most of the questions, and others have been replied in line in the question view. So thank you, and thank you for joining, and see you.